AI broke the internet again, and this week has been absolutely insane. Meta releases a new top open source 3D mesh generator that can produce artist quality meshes in under a second. Google drops a brand new type of language model that generates text 4 times faster than regular LLMs. Cohere releases their first open source coding agent, and it can run on a single GPU. We have a new open source world model for robots that works across multiple different robot bodies. ByteDance releases a self-evolving AI that can judge the quality of images without any human-labeled data. We have a new open-source real-time motion capture tool that can animate 3D avatars using just your webcam. And we have a new open-source robot with some really impressive dexterous manipulation and a lot more. So let's jump right in. First up, Meta releases a really impressive 3D generator. It's called Meshflow, and this can take a point cloud or an image and generate a clean, artist-like 3D mesh from it. Now, if you're not familiar, a mesh is basically the underlying 3D structure of an object. Think of it as like the skeleton or wireframe that 3D artists use to build characters, props, and environments in tools like Blender or Maya. And what makes Meshflow special is the quality of the meshes it produces. These aren't just rough approximations. The vertices and edges are clean and well organized, basically the way a professional 3D artist would model them by hand. Here are some examples. You can see how it takes a surface point cloud and generates a really clean mesh with proper topology. And as you can see, the resulting mesh has well-distributed vertices and clean edge loops. Here's another example where you can see it reconstructing objects with really accurate geometry and connectivity. Now, how this works is instead of predicting mesh tokens one at a time, which is what most previous methods do, Meshflow uses something called a mesh VAE to compress the mesh into a compact, continuous, latent space. In other words, it learns to represent meshes as smooth vectors instead of discrete tokens, which avoids quantization loss. And then, a flow-based diffusion transformer generates all the latent tokens in parallel rather than one by one. In simple terms, think of it as like the model is filling in the entire 3D shape all at once, rather than drawing it point by point. And this makes it 18 times faster than previous autoregressive style mesh generators. For your reference, Meshflow can generate a complete mesh in under 1 second. Pretty crazy. The awesome thing is they've released this already. So if you click on this GitHub repo here, you can scroll down and find all the instructions on how to run this locally. They've also released a live Gradio demo on Hugging Face if you want to try it without setting anything up. This is from Meta AI, and it was accepted as a highlight paper at CVPR 2026, which is actually one of the top computer vision conferences out there. If you're interested in reading further, I'll link to this page in the description below. Also this week, Google releases a pretty interesting new type of language model. It's called DiffusionGemma, and this generates text in a completely different way compared to regular LLMs. The problem with standard language models like GPT or Gemini is that they generate text one token at a time, left to right. Each new word depends on the word before it, so your GP2 is basically sitting idle most of the time while it waits for each token to be computed. DiffusionGemma solves this by generating an entire block of 256 tokens all at once, in parallel. It starts from a canvas of random placeholder tokens and then refines the whole block across multiple denoising passes until readable text emerges. Think of it as how image diffusion models take noise and gradually turn it into a sharp, clean image. Same idea, but for text. Because it processes everything in parallel, it can generate over 1,000 tokens per second on a single H100. That's up to 4 times faster than regular Gemma models. The awesome thing is this also has a really cool self-correction ability that autoregressive models can't do. It can re-noise and replace tokens during refinement if its confidence drops on a particular word. In simple terms, it can go back and fix its own mistakes mid-generation. Now, the one thing I'll note is that DiffusionGemma does score lower than standard Gemma 4 on quality benchmarks like MMLU and coding tasks. So Google is positioning this as an experimental model for speed-critical local use cases rather than a replacement for their main models. It's not meant to compete with Gemini directly. DiffusionGemma is a 26 billion parameter mixture of experts model, but it only activates 3.8 billion parameters at inference time. The GGUF quantized versions fit inside around 18 gigabytes of VRAM, so you can actually run this on an RTX 4090. They've released this already under an Apache 2.0 license. If you go to the Hugging Face page, you can download the weights and run it locally. It's also available on Kaggle and Google Cloud's Vertex AI. I'll link to this page in the description below. Next up, Cohere releases a really useful open source coding model. It's called North Minicode, and this is Cohere's first fully open source coding model built specifically for agentic software engineering tasks. Now, what does agentic mean here? In simple terms, this isn't just a model that completes a line of code. This is designed to do things like plan out a full software architecture, manage subagents, do code reviews, run terminal commands, and handle complex multi-step coding workflows. Here's how it compares. Looking at Cohere's benchmarks against Mistral's DevStrol Small 2, a 24 billion parameter dense model, they claim North Minicode gives you 2.8 times higher output throughput and 30% faster inter-token latency under identical hardware conditions. Now, these are just their self-reported internal benchmarks, so take that with a grain of salt. If you look at Artificial Analysis, which is an independent evaluator, it ranks 18th out of 127 comparable open-weight models on the Intelligence Index, and 8th out of 127 for raw output speed at 210 tokens per second. So it's genuinely fast. One flag from the independent data. This model generated 75 million output tokens to complete the benchmark, compared to a class median of 25 million. In other words, it's quite verbose, which could be a meaningful cost in high-volume production workloads. For the architecture, North Minicode is a 30 billion parameter mixture of experts model, but only 3 billion parameters are active at any given time per forward pass. So inference costs are dramatically lower than a dense 30 billion model would require. It also supports a 256,000 token context window and can output up to 64,000 tokens. They've released this already under an Apache 2.0 license. You can download and run it from the Hugging Face page. It can run on a single H100 GPU at FP8, and it's specifically designed to work with OpenCode, but is compatible with most coding agents. I'll link to this page in the description below. Also this week, we have a pretty interesting new world model for robotics. It's called Oscar, Omni Embodiment Action Conditioned World Model for Robotics. And this is actually super useful for anyone working with robots. The problem with most robot world models is they're trained on one specific robot body. If you want to use the model with a different robot, you basically have to retrain everything from scratch. Oscar solves this by using a unified 2D skeleton conditioning approach that works across 4 completely different robot embodiments, as well as a human hand. In other words, it can simulate and predict what a robot will do across multiple different physical robot bodies using a single model. How this works? They fine-tuned Cosmos Predict 2.5, NVIDIA's robotics foundation model, on a curated dataset that combines robot teleoperation data and egocentric human video. The conditioning is done through 2D skeleton keypoints, which is a unified representation that can describe the pose of any body. Think of it as giving the model a common language that all robot bodies can speak. The whole thing is just 2 billion parameters, which is quite small for what it can do. And it was fine-tuned on a single GH200 GPU. They've released the code and the model already, The GitHub link contains all the instructions, and the model weights are up on Hugging Face. I'll link to this in the description below. Next up, we have a pretty cool new tool from ByteDance. It's called Evo Quality, and this is a self-evolving vision language model that can judge the quality of images without needing any human-labeled data. Image quality assessment is actually a really important problem. Anytime you're training a generative AI model, doing image processing or compression, you need a reliable way to automatically evaluate how good an image looks. What's awesome about Evo Quality is how it trains itself. Instead of requiring expensive human-animated quality scores, the model improves its own perception through something called pairwise majority voting. Basically, it generates its own pseudo-labels by comparing images against each other and reaching a consensus on which one looks better. Then it uses those self-generated labels to train itself further through reinforcement learning. The results are actually impressive. Evo Quality boosts its base model's zero-shot performance by 31.8% on image quality benchmarks. And despite being entirely self-supervised, it actually outperforms supervised models on 5 out of 7 standard IQA benchmarks, models that were trained on human annotated data. They've released this already. The model is available on Hugging Face, and the code is in the description below. Also this week, we have a super useful open source tool for creators and YouTubers. It's called SysMoCap, and this is a cross-platform, real-time motion capture system that can animate 3D virtual characters using just a regular webcam. It can track your face, hands, and full body all at the same time and apply that motion directly to a 3D avatar in real time. You can see how the bone tracking picks up facial expressions, mouth movements, and hand gestures very accurately, and the avatar mirrors the movements really cleanly. What's awesome about this is it doesn't require a discrete graphics card at all. It can actually run smoothly on an 8-year-old computer, tested on an i7-4790K with a GTX 770 and 16 gigs of RAM, and it still ran smoothly. That's actually incredible for real-time motion capture. It supports VRM format, GLB format, and Mixamo FBX files. So if you've ever created a character in VRoid Studio, you can just import it directly, and it works. It also supports OBS live streaming, WebXR for AR and VR, and is available on Windows, Mac OS, including Apple Silicon, and Linux. They've released this already. The GitHub page has all the instructions, and there are pre-built installers for Windows if you don't want to build from source. I'll link to this in the description below. In humanoid robot news, we have a pretty interesting new open source robot this week. It's called XR0-G0, and this is an open source dexterous manipulation robot from X Square Robot. What's notable about this one is it's specifically focused on pushing the frontier of dexterous robotic manipulation, fine-grained hand and finger control, which is actually one of the hardest unsolved problems in robotics right now. The results they're showing are quite impressive, with the robot performing really precise manipulation tasks that require careful finger coordination. They've released this already. The GitHub repo contains the full hardware design, software, and a dataset of 3,000 demonstrations on Hugging Face, which is really useful for training your own policies. I'll link to this in the description below. Also this week, we have a pretty interesting new open source representation for robotics research. It's called WorldString, and this is a new way to represent physical objects in 3D space so that robots can understand and interact with them. The problem with most 3D representations is they work fine for rigid objects that don't change shape, like a cup or a box, but they break down when dealing with things that can deform or move, like a soft toy, a piece of fabric, or an articulated robot hand. WorldString solves this by learning a set of structured tokens that are conditioned on key points. You give it a few key points on an object, and it learns a token assignment that can track how the whole object moves and deforms over time. They demonstrate this across 4 very different types of objects: a robot hand, a character doing football motion, soft, deformable objects like earphones, and even a Unitree Go 2 quadruped robot. The token assignments stay consistent even as the objects move and deform significantly. They've released the code and the dataset generation pipeline already. The GitHub link contains all the instructions with a separate repo for the data generation pipeline in the description. This is from researchers at Tsinghua University, UC San Diego, Caltech, and NVIDIA. A pretty impressive collaboration. I'll link to this in the description below. And that sums up all the highlights in AI this week. Let me know in the comments what you think of all of this. Which piece of news was your favorite? And which tool are you most looking forward to trying out? As always, I will be on the lookout for the top AI news and tools to share with you. If you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Thanks for watching, and I'll see you in the next one.